Physics is everywhere. Physics, 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 physics. Physics is everywhere. What a pitch! What a throw! What a hit!
Softball is a game full of excitement and technique. But what is that technique used to get that perfect pitch, throw, and hit?
In today's episode of Physics is Everywhere, we'll explore the physics and mechanics behind this intriguing sport.
Throwing.
Now we're going to show you how to throw.
You gotta throw, get your head in the game. You gotta throw, and get your head in the game. You gotta throw, get your head in the game. You gotta throw, get your head in the game.
With kinetic energy to a ball, a person does work on the ball, which means exerting a force over a distance. If the distance is large, the energy gained is more.
When Lexi is throwing, she is transferring her weight from her back foot to her front foot as her potential energy turns into kinetic energy in her body. Momentum is traveling through her body to her arm and into the ball, which carries it forward after the release. In addition, Newton's third law, which states, for every action, there is an equal and opposite reaction, is being explained because, as she is putting the ball forward and away from her hand on the release, the ball is pushing back on her hand with equal force.
As the ball is traveling through the air, it is spinning from the result of the Magnus effect. As the ball is traveling through the air, a layer of air forms on the top of the ball and stays on the surface. On one side of the ball, the air particles on the surface collide with the air passing by. On the other side, there is no air resistance. The side with the resistance is slowed down, creating a high pressure area, while the other side is faster, which creates a low pressure area. The seams on the bottom of the ball are going with the direction of the air, so all the high pressure over the top of the ball and the low pressure on the bottom are making the ball revolve in the air and spin towards its destination.
Pitching. Do you want to be pitch perfect?
Turn the beat around, love to hear percussion.
Not that kind of pitch perfect. Softball pitch perfect.
Learning how to throw is fundamental to the game of softball, but another fundamental action is pitching. The question is, what goes into a functioning fast pitch?
You might not be surprised to hear that the physics behind pitching is not that different from that of throwing. The concept of momentum in pitching is the same as in throwing. As weight is transferred from the back right foot to the front left foot, the ball is being moved by the forward momentum through the body and the arm. The body will continue to move forward until stopped by the left foot for a right-hand pitcher, propelling the ball forward at the release.
The Magnus force is also in effect when pitching, and essential to the spin on the ball, making the ball revolve as it travels towards the batter. The major difference that separates pitching and throwing is the centripetal force experienced by the ball as it moves in a curvilinear motion of the pitcher's arm during the windup of the fast pitch. The arm of the pitcher acts as the axis of rotation, and the ball is experiencing a force towards the center of the axis, which is the shoulder of the pitcher. When the ball is being released, it goes into the direction that is perpendicular to the pitcher's arm. So an ideal pitch would be released when the arm of the pitcher is perpendicular to the ground. Therefore, the ball will travel in a straight path towards the batter.
Hitting. We've learned about the physics behind throwing and pitching, but what about batting? How can physics relate to hitting a softball? And what's the physics behind that home run hit?
Sway. I got to just do my thing. Gotta hit.
The physics behind batting is very similar to the motion of throwing in that the momentum used when stepping from your back foot to your front foot is transferred through your body and arms, twisting the batter's shoulders, and into the bat, thus making the bat swing. When the bat hits the ball, it is a partially elastic collision, resulting in the ball changing direction due to the force of the collision. When the bat and the ball collide, Newton's third law is exhibited because, as the ball is being forced forwards, the ball is pushing the bat backwards with an equal amount of force. But getting a home run hit does not solely depend on the force of the hit. It depends just as much on the angle of the bat as it hits the ball. For example, if the ball is thrown at a 95 kilometers per hour, a 10-degree increase in the angle of the bat can increase the distance of the ball by 5 meters, and a 16 kilometer per hour increase in speed upon hitting the ball can increase the distance of the ball by 7.5 meters.
If the force on the bat on the ball is maintained for a larger distance, the work of the bat on the ball will increase, which increases the amount of kinetic energy transferred to the ball.
Now that's physics in action.
Physics is everywhere. Physics, 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 physics. Physics is everywhere.